The central limit theorem. So what happens now is, instead of saying find the probability that one person has such and such, or find the probability that one scores such and such, what we're going to do is say we have a group, and what's the probability that the mean for that group does such and such. Take a look at this non-numerical example. Which has a higher chance of happening? You randomly choose a person, turns out they're a genius. You randomly choose 40 people, turns out they're all geniuses. Obviously, part B has a much smaller chance of happening, because if you choose 40 people at random, most likely there's going to be some people that bring down the average or are not geniuses. Alright, so what happens when you have samples of size n? So we still are going to be using the z-score. So what we really need to know is, if you have a sample of size n, how is that going to change the formula? So if you break down the central limit theorem, it basically says that the average of the averages, so in other words, you take all groups of size n, so out of the population you decide, I'm going to take groups of size 35. You take all the groups of size 35 and you find the mean. Well, it turns out that the mean of all of those means is going to equal the overall mean. Which is good news, because that means that in this formula, this number does not change. Then, what about the standard deviation? Well, the standard deviation does change. What you need to do is take the original standard deviation and divide by the square root of n. So that's pretty good news, because what that means is there's only really one thing that's added in this section, and that is we still do the z formula, but it's now going to be divided by the square root of, the standard deviation will be divided by the square root of n. So back to this example with the IQ scores. And this is actually an example from the previous section, but this is basically saying, all right, what's the chances that you find one person that's a genius? And by the way, this is supposedly the cutoff for being a genius if you've got an IQ over 132. Google it, check it out. So you do the bell-shaped curve with mean of 100 in the middle. Here's 132, do the z-score, we get a 2.13. Then look up a 2.13, which would be 2.13 would be right here. 98.34. So that means the left side is 98.34. If you do 1 minus that, you'll get 0.017, or in other words, 1.7% of people are considered to be geniuses. 1.7%. Now what I'm going to do for part B is do basically the same thing, except instead of one person, what if it was 40 people? So you randomly choose 40 people, and their average IQ needs to be over 132. So take a look at this. The only difference is, right in here, you need to divide by the square root of 40 people. That's how the standard deviation is affected. When you do this, make sure you put the numerator in parentheses, the denominator in parentheses, and in this case, you would end up with a 13.49. Now, this is the first time that we've run across this in this class. If you look at the table, so I had to sort of push it up so you could see. If you look at the table down here at the bottom, it says if you're looking for 3.5 and above, then just use 0.9999. And that means the left side is 0.9999. So that means the right side is 1 minus that. So that means the right side is 0.0001, which is a much smaller answer than we got before, just as predicted with the very first example. The next example, there's a normal distribution for men's weights, an average of 172 with standard deviation 21 pounds. there happens to be an elevator. It's got a maximum capacity of 1,910 pounds. Suppose that 10 men get into the elevator. So what's the probability that it's overloaded? Sort of a engineering problem. You know, the engineers, whoever made the elevator and the shaft and all of that, they need to know, well, what are the chances that if 10 guys get in this, that it's going to be overloaded and perhaps break? Well, since it's 10 guys and it's a total of 1,910 pounds, basically, if they all average more than 191 pounds, then for 10 guys, it's going to be overloaded. So what we really need to do is find out what's the probability that their average is over 191 pounds. So draw the picture, bell-shaped curve, 191. You do the z-score, and again, because it's 10 guys, you divide by the square root of 10 and get a 2.86. So we then look up a 2.86, which is a 99.79.